We're going to be talking about functions and function notation. Functions are just a special type of relation, guys. They're just sets of ordered pairs. They just have special properties about them. So let's get down some formal definitions and we'll go from there. Starting off with, a function is a relation. So starting off with, the very first thing you know is that it is going to be a relation, which all that means, guys, is it's a set of ordered pairs. Right? It's going to be a set of ordered pairs. Now there's some categories or some classifications that need to go with it, some caveats that you need to know about, things that you can't have or you can't have to have in order for this to work. So it is a set of ordered pairs in which each member of the domain, guys, what's the domain? All the what's? All the x's. Each member of the domain, meaning each x, is paired with exactly one, this is key, exactly one member of the range. And guys, what's the range? Y's. Okay, I'm going to give you a minute to write that down. A relation, basically a set of ordered pairs, in which each member of the domain is paired with exactly one member of the range. Okay, that's their fancy definition, and it is the true definition of it, guys, but I'm going to try to give you a way to make it so that it's easier to understand. The whole idea is that the domain cannot repeat. Bless you. The domain cannot repeat. If the domain repeats, it's not a function. Okay? The whole idea of a function is if you plug in an x, you're going to get a y. It's going to match up 1 to 1. Okay? So if it doesn't match up 1 to 1, if x, when you plug it in, can give you more than one thing, then it is going to be a problem. So you're going to have no repeats. Let me say this again. No repeats in the domain. The x's cannot repeat. This is the x's. Domain cannot repeat. The x's cannot repeat. Can the y's repeat? All they want to. Okay? But the domain, the x's cannot repeat. Domain cannot repeat, guys. Okay, guys, so think about this. X-axis goes this way. If you had more than one thing on the x at the same point, so let's say x, here's the y-axis, let's say x was 3 right here. Okay, that's the point, 3, 0. If you had one repeating here, that would no longer be a function because this would be the point 3, 2. And then if you had another one down here, 3, negative 2, again, not a function because you've got a repeat. You've got x being the same thing. Vertically, it cannot repeat. Now we'll talk more about that. I just want to explain what the concept is. The x's cannot repeat. Okay, the idea of a discrete function, guys, it's very straightforward. It's just going to be a function that is a set of unconnected points. A function that is a set of unconnected points. A function that is a set of unconnected points. Think about all those things you graphed yesterday. Remember all those things you graphed where you put points on there? How they weren't connected to each other? Those are discrete functions. Everything that's just got a bunch of points on it, those are discrete functions. When they don't make something, they don't make a line, they don't make a curve, they don't make a V, they don't connect to each other, That makes it discrete, guys. Discrete just means that it's unconnected. Make that idea, that's what you need to remember out of it. Discrete means they're unconnected. That's it. That's the basic idea. If it's discrete, they're not all connected. Now, what do you think continuous means? They are connected, exactly. Continuous means they're connected to each other. So when we're talking about continuous, it's going to be a function, excuse me, a function that is a set of connected points. So continuous means everything is connected. Continuous means they're connected. All right, now guys, you're going to see things like a line. That can be a continuous function. You can also have curves. Does anybody know what this is called? It's not just a curve, it's got an actual name. Huh? Parabola is correct. Yes, that is a parabola. That's a continuous function. Okay? You can also have something that looks like this. This is a V. This is formed when you solve an absolute value problem and you graph it. Absolute value problems have positive and negative cases, so they have two lines that make a V, either going up or going down. We're going to do those. We're going to graph all this fun stuff eventually. These are all examples of basic continuous functions. Now, guys, that's all the info that we're going to get. Now we're going to talk about the things that look like the homework that you're going to be doing as far as things that you do with this. So all you're deciding is something a function or is it not, based on this definition and these rules. Okay? Is it a function or is it not? It's a yes or no question and you have to tell me why. It's not something that's really crazy, guys. These are not complicated. You just need to know the basic idea that a function has no repeats in the domain. No repeats in the domain. Okay, guys. Oh, anybody still writing? Yep, take it out. Okay, thank you. Guys, that's all I need you to do is communicate with me. That's easy. I'll wait for you. Okay, guys, so is this a function? All you're doing is looking at the domain. Guys, what's the domain? The x's. So the only part I care about is the x's. The x's of the domain. That's the only part that matters, because the y can repeat all it wants to. So, is there a repeat in this?
Yes.
Yes. That means, is this a function? No. And the reason is, I have to be specific. Please listen to me. 0 repeats in the domain. You have to be specific and tell me exactly why it doesn't fit a function. I have 0 repeating in the domain, therefore this is not a function. Okay. Now, that was a set of ordered pairs. When you look at a table, the x's are even easier to find because the x's are now in a line. They're just all lined up right here for you. Is this a function? Yes or no? Nope. And why? 2 repeats. If you only say 2 repeats, you'll be marked wrong. In the that's not a D. Let's try that again. In the domain. 2 repeats in the domain. Okay, guys. The next one. Mappings are a little bit harder for some people to see. Some people see it right away. These are your numbers, but just because there's not a repeat here does not mean that there isn't one. How do you decide if there's a repeat when you're dealing with a mapping? Yeah. Thank you. If 2 arrows come from the same number. So there are 2 that go to the 6 over here, so the -6 would repeat, but none of these have 2 arrows coming off of them. Okay? If there were two arrows, then the answer would be no, and you'd say whatever that number is repeats in the domain. In this case, is it a function? Yes. And why? You have to be specific. Thank you. No repeats in the domain. Now, that's the first type of problems you're going to see on your homework. You're going to see that for, I mean, it's numbered weird, but that's problem numbers 20 through 20, like 3. And then 27 and 28, you've got some random numbering on this. So you're going to see this type of problem. Anybody see anything about this you need to ask about? Wonderful. I'm not going to spend any more time if we don't need it. Is everybody good on that concept? Can you repeat in the range? Yes, you can repeat all you want to in the range. The only thing that matters is no repeats in the domain. Yeah. You got it? Okay. Okay, guys, here we go. The vertical line test. This is the exact same thing, but you're doing it visually. Guys, sometimes you're going to get things, and they're going to ask you about a graph, and you're going to have to decide if it's a function. So we're going to use something called the vertical line test. This vertical line test is abbreviated VLT, very happily, because we don't have to write out vertical line test every time. So I would write a big VLT out beside this, and you need to know that that stands for the vertical line test. You can always write it out, but that's a lot of writing. Trying to help you here. So the vertical line test is used to decide if something is a function. Okay? Whenever you draw it, if the graph only hits once, listen, if the graph hits only once, then it is going to be a function. Then it is a function. If it hits 2 or more times, then it is not a function. So guys, if it hits once, it's okay. Twice, it's out. Why? Because guys, if I have 2 points vertically, they are going to have the same x value. They're going to have the same x number if they're in the same line vertically. Now, you can take your pencil and just slide it across. I'm actually going to draw a vertical line so that I can actually slide it across. So I'm going to go right here. I'm going to take this. I'm going to draw it. So, well, that would be good if I changed color first. So here's my vertical line, and I'm going to start sliding this across. Oh, not bad. See if I can get the little line that I drew. Okay. Is it a function when I put it right here? Yes or no? Yes. Is it a function when I put it right here on this line? Yeah, it only hits in one spot. Is it a function when I get here? No. So draw a line right there where it hits 2 points, because we're going to draw a vertical line. Just sketch. It doesn't have to be perfect, guys. Okay. Put something here so you can see it hits here and here. And you're going to write, no, it is not a function. And it's a pass-fail, guys. It's a test. So it fails the vertical line test. It's no because it fails the vertical line test. Why does it fail? Because it hits twice. If it hits twice, it fails. Questions, concerns, anything so far? Okay, let's slide that line over. Y'all already have yours drawn on there, so you're good. Let's pull it over here. Right here. Is it a function? Yes. Right here, is it a function? Yes. Right here, is it a function? Yes. Don't answer right away. Think about this. No. Right here, is it a function? Yes. No. Yes. No. Yes. It is. Why though? It's hard to see, but guys, what kind of dot is that right there at the bottom? This one right here is what? This one is closed. This one is open. Does that mean it's actually part of the answer at that point when it's open? No, it's actually just a border. So because it's only got 1 point right there that's shaded in, it is actually a function all the way across it. I didn't see that. So yeah, that's why I pointed it out. It's hard to tell. You can see it up here a little better than you can on your paper, but it is. So it's going to be, yes, it is a function. And what's the reason, guys? Passes the VLT. Passes the vertical line test. Okay, guys. So I'm going to draw a few more on this side that would fail, and I'm going to draw a few more on this side that would pass. I would suggest you draw them out to the side, just so you have them. It's easy to keep up with. So let's draw one over, well, let's draw some fails first. Okay, let's draw one that looks like this. You see right here, this would fail because it would hit in two spots. Ooh, what about this? If this line was vertical, if I could draw, and that was straight up and down, passes or fails? Guys, it's a vertical line. How many points does it hit vertically? All of them. It hits every single point. Is there any point that's not on it? No. So that fails because it hits not only more than once, it hits infinite number of times. Okay. What about over here? Does this pass? Yes. Does this pass? Yes or no?
Yes.
Yep. Does this one pass? Yep. What about that? Yep. All those pass. All different types of things that pass. They only get hit once. If you drag a line across it, it would only hit one time. So failures, passing. Anything about it. Okay, that's the second type of problem you're going to see. That's actually the first 4 problems on your homework, plus 24 and 25. Does anybody see anything they need to ask about? Okay, last thing is function notation, guys. This can be complicated or it can be easy. Guys, don't make this complicated. This is just a different way to write the exact same thing. Function notation looks like this. Here's your equation. Y equals 3x minus 8. Function notation says f of x, the function of x, is 3x minus 8. The only thing I did was to take the y and replace it with the word, or the little expression right here, f of x. Okay, so guys, y'all understand that y is the same thing as f of x. No, you don't have to write that down, but if it helps you, you need to just understand that it's just a different way of writing the equation. That's all it is. Don't make it more than it is. So if I tell you that this problem has a domain that is equal to domain is all the what's, x's. I'm going to tell you this has a domain of -2, 0, and 3. And I'm going to want you to find the range for this function. Guys, what would you do? Plug it in. I've got numbers for x. I'm going to plug them into the function notation. This is the way you write function notation. Don't let this be complicated. Here we go. It's going to be f of, instead of putting the x in there, we now write a -2. Wherever the x is, you put a -2. So it's going to be 3 times -2 minus 8. That's all it is. Just wherever the x is, you replace it with a -2. You have a calculator that will do this part for you. Type 3 times -2 minus 8. 3 times -2 minus 8. What does that give you? -14. There we go. So the first part of our range is going to be -14. Guys, all it is plug. You understand this? Did y'all ever have the problem that said evaluate for, and you plugged in numbers for the variables? That's all this is, in just like a different way to write it. All right, here we go again. Please. You got to speak up. Where did I get the numbers? What? I had to give it. They have to give it to you. Yep. They have to give it. It's part of the problem. You can't come up with that out of the blue. So that's the part they give you. All you're doing is finding the range by plugging them in. Literally all it is plug in the numbers, get an answer. Do the arithmetic. Good question. Anybody else? Yeah, please. Where did this come from? From over here in the domain. They gave you these numbers and said, here is the domain. And I'm taking these numbers and I'm replacing them in here where the x was and where the x was. See the x here and the x here. I'm putting them in those spots. Wherever the x is, I replace it with the -2. Keep asking. No, I didn't do anything to get the -2. That had to be given to me. The domain was given to me over here. They gave me these numbers and I'm plugging them into the problem. Keep asking. Yes. In this case it is. It's telling me the domain is -2. Is that the only number that x is, guys? What are the other numbers that we're going to plug in for x? 0 and 3. Why? Because they're the domain. And what is the domain? It is all the x's. Better? Keep asking. Go ahead. They have to give them to you guys. Guys, I've said that like 3 times. I'm just trying to make sure I don't know someone else maybe help them. This is part of the problem. They have to tell you what to plug in order to know what you're going to have to plug into it. You can't just come up with that. They're giving you those numbers. They're saying, here's the domain, find the range. Okay, yep. Yeah. Yep.
If they give you the range, do you have to divide?
No, they're not going to do that. No, that's a good question, but no. So guys, we plugged in -2. What's the next number I need to plug in place of that? 0. So it's going to be f of 0 is equal to 3 times 0 minus 8. All I did was, again, I took the next number that they asked me to plug in and I put it where the x was. Now it's just arithmetic. I'm going to say f of 0. If I plug it, that means if you plug in 0, this is the answer you're going to get. Alright? So what's 3 times 0 minus 8? -8 or minus 8, however you want to say it. Now what do we plug in? 3. F of 3 equals. How did I know to plug in 3? Because it was the next number in my domain, which is the next x. So it's going to be 3 times 3 minus 8. F of 3 equals, what is it, guys? 1. Because 9 minus 8 would be 1. Okay. So my numbers that go in my range, what are the 3 answers? -14, what's next? -8 and 1. Questions. Keep asking. If you need to ask more questions, ask them. I do not have a problem with that. You need to understand this. If there's something you don't get, ask me. It doesn't bother me for you to ask more than one time. Like, if I don't explain it the right way that makes it make sense to you, then someone else in the room might say it in a way that makes sense to you. Questions? Okay, guys, the rest of what we got is just function notation. All we're going to be doing is plugging into different functions. There's one that's an f of x. There's one that's an h of x. They can use any letter in front, guys. Usually they're f, h, or g, but it doesn't make any difference. Whichever letter's in front, that's the function you plug into. On your homework, you're going to have 2 different functions. They're based on the letter. Whichever one has the same letter as in front, that's the one you plug into. So, let's show you what the problems are going to look like. So tonight's homework looks like this. F of x equals 3x minus 4. Find these functions. They're telling you what to plug in. Do you see where they're telling you what to plug in? It's right here. Instead of f of x, you're going to do f of 4. Instead of f of x, you're going to do f of -5. Instead of f of x, you're going to plug in 2 minus x into the problem. Yes, you can plug in variables. You can plug in anything. Yep. No, it's not always going to be, because look on the next slide. The next one is h of x is x squared minus 4x plus 5. So it can be any function it wants to be. It depends on what they give you up here at the top. They have to give you the problem every time. Do you see it?
Yes.
Okay, that's okay. Here we go. Let's plug into it. So f of 4 equals, guys, all I do is replace the x with what number? 4. 3 times 4 minus 4. So f of 4 equals, well, 3 times 4 would be 12, and 12 minus 4 would be 8. That's it. Don't make this more complicated than it is, guys. I'm telling you, you can make this hard. Don't. It's just plugging in and using your calculator to do arithmetic. That changes when we get a variable in it. Then it becomes a little more of the combining like terms and things like that, but you'll see that when we get down here. Okay, on this one, we're going to be plugging in 3 times negative 5 minus 4. F of negative 5 is going to equal, don't say it yet, let people try it. It's going to be 3 times negative 5 minus 4. 3 times negative 5 minus 4. What do you get when you type that in on your calculator? What is it, guys? Negative what? 19. Negative 19 is what I got. 3 times negative 5 would be negative 15, and negative 15 minus 4 would be negative 19. If you need help on the calculator, let me know when we get done. Okay, last one of these, then we'll go to the last page. So we're plugging in 2 minus x. Guys, you do the exact same thing, but inside the parentheses, instead of just putting 4 or negative 5, you put 2 minus x, and then write the minus 4 on the end of it. What property is this? Thank you, distributive property. When you have a number outside of a parentheses with more than one thing inside of here, you've got to distribute this across. That means you're going to rewrite it as f of 2 minus x equals okay, guys, 3 times 2 would be 6 minus 3 times x would be 3x, and then the 3, does the 3 get multiplied times the 4? No, guys, the 4 is just on the outside. It's just minus 4 comes down. That's it. Don't do anything else. That's it. That's where we go to do our combining like terms. At this point, the only thing we have left is to put together our like terms. These two need to go together because they are both constants. They are both just numbers. So on this next line, we still write f of 2 minus x. Write it every time, guys. That equals. Whatever's over here equals. And then we write the variable term in front, so it's going to be negative 3x goes in front. And then what's 6 minus 4? Just 2, so it's plus 2. 6 minus 4 is positive 2, so all you do is write plus 2 on the end of it. Now I need questions on this before we go to one with a square in it. Does anybody see anything that they need to ask about before we start doing the last page? Starting to see where you plug in. Is it okay? Getting better? Is that getting better? Just want to make sure. Okay. The last thing that we're going to be doing is plugging into one that is actually going to graph into a problem. Just so you know, it's called a quadratic function. We're going to be dealing with these a lot. We deal with quadratics all the time as we go forward. We're going to graph these, do all kind of things with these, solve them, lots of stuff. So this is going to be something we deal with a lot. Right now we're just talking about the function notation of it. So they want us to plug in negative 3 in place of the x. So we write an equal sign. Where the x is, we put in a negative 3 and we put a squared minus 4 times negative 3 plus 5. Guys, this is one long calculator problem. H of negative 3 should be something you can type in on your calculator, but grab it because we need to talk about typing this. Okay? To type this in on this calculator, you have to type the parentheses when you're dealing with a square that has a negative with it. So you've got to type parentheses, negative 3, close your parentheses, then hit the square button. The square button is the one that looks like this. X squared. That key. Then you're going to hit minus 4 times negative 3 plus 5. Hit equals, what do you get? 26 is your answer. That's just calculator work, guys. All that is just calculator work. listen to me. If you don't put these parentheses around the negative when you square it, you're going to get the wrong answer. This calculator is smart. If you don't have a parentheses here, it actually turns out to be a negative because you're only squaring the 3, not this whole thing. It matters. You got to put parentheses around something when you square it. It's got a negative. Okay, on the next one, we're going to be plugging in 6y where the x is. So it's going to be 6y squared minus 4 times 6y plus 5. Does everybody see that all I did was put a 6y in here wherever the x is? These two spots, I put in whatever was there in that spot, which is 6y in this case. Questions just on the plugging in? Okay, guys. H of 6y equals, guys, what's 6 times 6? 36. And then the y, guys, when you multiply y times y, you're just going to move the square down to the y, so it's going to be 36y squared minus 4 times 6y is going to be, guys, 4 times 6 is what? 24. Just put the y on the end of it, and the plus 5 goes on the end. Are any of those like terms? No. They have y's, but are they raised to the same power? No, so you can't put them together, guys. That's a quadratic. You'd leave it like that. That's actually listed in the right order. It goes from the highest power down to the lowest. That's it. You're done. That's all you can do, guys. That's the answer. Okay, last one I put on here because people freak out when they see this thing on the outside. Guys, listen to me. To start the other part of it, see how the negative 4 is on the outside? Put a negative 4 and then put a bracket. We're going to leave the negative 4 on the outside. Then the only thing we're doing is replacing the x with a what? W. So basically, do y'all understand all we're doing is changing the letter? We're changing it from an x to a W. That's all we're doing. Put it in there. W squared minus 4w plus 5. Okay, why is that not my final answer? Because I need to do what? What property is that when something's outside of a parentheses or bracket? Distributive. I have to multiply everything in this problem by this negative 4. So when I bring this down, I bring down the negative 4. I bring down the h to the w. And then I multiply. Guys, all I'm doing is multiplying the negative 4 times each individual piece. So negative 4 times w squared is literally negative 4w squared. Ooh, what's a negative times a negative? Positive. And 4 times 4 would be 16 what? W. 16w. Nice. And then a negative times a positive is going to be a negative, and 4 times 5 would be 20. Are any of those like terms? Do they have the same letter? Yes. Are they raised to the same power? No. So they are actually just like they need to be. They go from the highest power down to the lowest, and there's none that we can combine. Questions? Nice questions today. Yes, please. Can you? No, absolutely not. That's a very good question.